Welcome to Grover Load. I'm Anthony, and I want to talk a little bit about this melting issue that's happening with Nvidia's adapters for their 12-pin adapter for their 4090s. That's the 12 volt VHPWR 12 volt high or 12 volt high power cable adapter. And I want to talk a little bit about that, some of the melting. I'm not going to come to a conclusion because there's a lot more work than just taking apart a connector or anything else is going to do to make it so oh yeah, we have this down. But Eager Labs did a nice write-up of this, and I'll post a link in below for that, as well as actually hardcore overclocking. Go take a listen to some of his videos. They're about 30 minutes each, but he does a really good job kind of going through his thought process on all that as well. I actually have a two 6 pins to 8 pin to do some demonstration here as I needed, but I find it kind of interesting is how some of the cables, or I find it interesting how you're seeing this with the Nvidia one for the most part, the Nvidia 12 volt. Now this is something that can pull up to 600 watts across this cable, whereas an 8 pin is what, roughly 150, I believe, is that what's rated for. And as you see here, the 8 pin is, I wish I had a 12 pin to compare to, but the 8 pin is a lot, is pretty big, right? The new 12 pin uh, is going to be, for 12 pins, it's quite small. And inside here, you'll see those little metal connectors. If the camera decides to focus on this rather than me, come on, focus on something good, on what I'm trying to get to here. So you see those little metal connectors in there, right? And if you can pause just right, you'll see that there's a couple different ways you can design this, right? In this one, it has slots on top and bottom. So as the pin comes in, it will um, open up, and as it comes out, it's supposed to collapse. So you're supposed to have contact across that entire substrate, basically there, right? If you don't have enough contact, that is, more resistance and will generate heat, and you get into this bind issue and everything else. You can have runaway areas, all that fun stuff. But let's keep it simple for right now. And so if you have where it has that gap, so you have that slice on either side, and then it inserts, and that way, it can be tight in there, right? But let's say you have now twisted it, and so these are up and down. Yeah, so let's rotate the cable. So now you insert it and you twist it. Well, where you're bending the cable, you're going to have a slight issue, right? You bend the cable this way, right? You might not have that full contact on either way. That may be some of this too, right? You're going with a new design and a new connector, right? It's the same type of philosophy as these 8 pins. However, it's less material, right? It's a more dense connector overall. So my first thought is that hardware overclock was doing this, and he also mentioned that the new Corsair ones, they only have the Corsair cables, or the cable mod cables. They only have, instead of having a slice on the top and the bottom for that pin, they only have one slice in it. So it's three-sided, which you're going to have a reduced, just there, right? You have a reduced amount of ability to bend it at all. So if that's the case, well, that could be an easy fix. Also, it could be um, that could just be one fix to it too. Then you go into Igor Labs, and let's see here, Igor Labs. Um, I'll post all these below. I'm trying to remember which one it was at Eager Labs here. He has, you can see here some of the melted pins, and here's how all the pins are mapping, but they're soldered. And can be part of the problem too, where they're kind of bringing all the cables up and having all four, see, one, two, and here's the sense wires for the IC. You're having all these brought up and being soldered in rather than having them ran direct, or as Eager Labs did it crimping. He said crimping is how they should be doing it. Now you have just this problem just naturally, right? Because this is going to be the first generation of this cable, right? And this is going to be a huge transition. I believe this is part of the ATX 3.0 spec. This is, something by the PCI SIG has been known about, the maybe some melting issues with these cables. You have these pin issues. My guess is it's a combination, right? You have some failure here with the soldering, and he goes into crimping here and through this. Oh, I already had that one open. Well, you're going to see it twice. But he has some where you have done soldering here, which is another failure point, right? If you bend this, you're going to be having another issue. It's going to break over time. Solder isn't permanent. And then you have the sense wires. And then so let's see here, you bend it like that. You can see there's a little bit melting here. You can see that they are split top and bottom of the pins. They had already had observation at PCI SIG, and this is from Cable Mod. Said, do not bend vertically, do not bend horizontally. You have to wait 35 milliliters to bend. So I believe Cable Mod even has a cable now. They're going to come up with a 90-degree and then, well, a negative 90 is what I'm going to call it. So they bend each direction, and you have so you can avoid this issue. And I think that's going to be the, where this is going to start. Nvidia, from things that have been reported from Igor and other people, said that, hey, Nvidia is very serious about this issue. They've been working hard to figure it out. I think it's, could be a multitude of these two things, right? Maybe there's the third thing, which I think is very highly likely, is this is the first generation of doing this adapter this way. May never be done this way ever again, but this adapter maybe will be going in a different direction going forward. Maybe they will do crimping, maybe they will do something else, or maybe they'll just have it where we're going to work with the power supplies manufacturers to get this cable into your hands and make it that way. Or another thing is to increase the tolerances of error, um, well, decrease that tolerance of error, right? What I'm just spitballing here numbers, but let's say they had a 5% error rate on the pins, 5% error rate on the connector itself, 5% error rate on the solder. Well, that all starts to add up, and then all of a sudden you're starting to see some of these connectors melt here and there because of because of the error in the manufacturing process. If you can tighten that up, does this all go away? I don't know, right? I was talking to my brother about this a little bit. He's a mechanical engineer, works in quality, so he works in trying to get a lot of quality stuff down. And we're going through numbers, right? It could be as a problem as we didn't have our quality ratcheted up enough to catch all these errors before they came out in these 12 volt or 12 pin power connectors, and now we're just trying to get it through, right? Another thing, people are trying to out there looking at the plastic housing with a thermal camera. While that may provide some detail of interest, you're not going to see what the actual temperature of the cable is. And like actual hardcore overclocking was going into and saying, hey, you'd have to put a thermal sensor, wire it all up there. If you wire it up, you may actually not have the air anymore because you may tighten it up. That's something I was thinking about too. This overall is a hard problem, right, that needs to get fixed. I don't think Nvidia was expecting this. A lot of times you're not going to even notice it is melting until you unplug that power adapter to check on it. And from what is seen out loud being reported is that Nvidia is taking a keen interest in this, which is a good thing. I mentioned that I don't think this will stop this power connector going forward. However, I do think that if Nvidia does not get on top of this, it could completely make a negative connotation of this connector going forward in the DIY space, which would be a huge detriment. So that's kind of just something I had about this cable, right? I hope that they come out with more cables where they do, hey, 35 millimeters out, you can't bend or anything. Well, that's going to really hurt ITX. Uh, Even with how big a RTX card is, I bet you in this case that I have, the Corsair Crystal 570X, it's a pretty big case, but I bet you it would have issues. And a lot of the cases I've built in lately would have issues. Um, 35 millimeters are a lot. I kind of wish they kept the angle of the connector on the 3090 in the 4090. That would have probably helped a lot of their issues overall. Who knows, right? This is one of those things of I want to put my a little bit of what I think about this connector in there, but you know, cable mod coming out and everything else. I think that they're gonna. It seems like Corsair cable mod have not had issues. These third-party cables like Nvidia's adapter, and I think that was just some choices Nvidia had. You know, Nvidia makes a huge metal shroud on that 4090, not cheap. You'd think that they wouldn't have cheaped out here, and maybe underneath their testing was fine, and who knows how controlled that testing was. It's a new product, it's a new adapter, and when you spend $1,600, you want it to work. I get that. And that's something that NVIDIA is going to have to really look at, because this melting is not something you want to have going on in your case. Uh, you know, if something were to happen, I'm sure that there are governments like in the EU that would just say, I mean, that this EU has been known to just kill connectors, right? This is one connector where, let's say, basically first generation, pulling this much, pulling what, to three-quarters of its full potential. And if it has issues, I could see the EU going, yeah, we don't like this connector. That would be, oh, with all the work that NVIDIA and Intel have put in this connector and PSIG and, you know, this what is part of ATX 3.0 spec for power supplies. Oh, that would just be a headache. But we know AMD has came out and said we're not going to use it, and we can only go from there to see what happens for the next generation. Intel didn't use it for their ARC cards, but I'm not surprised. I don't know if anyone would expect ARC to have used it, considering where it landed in performance. So with that, let me know what your thoughts are on the melting issue. I'll be more than happy to listen to your thoughts, because I think that this is one of those things where it's going to be a bunch of learning of what happened, and I don't know if we're ever going to know exactly if there was one failure point or if there was a quality control issue, that we had multiple failure points, and it just happened that there's a certain number of cables that had a lot of those percentages just line up on each part, and they're causing the failure. So thank you guys for watching. Thank you for taking the time to help support Grow Everyone, help this channel grow. I really appreciate it. Until next time, God bless. Don't forget to like, share, and subscribe.